Hello everyone, let us continue, try to finish the syllabus for 2020, Maths 1641, Maths 1241. We now look at what we refer to as improper integrals. We have type 1, where we talk about infinite limits of integration. Number one, you will find that sometimes f of x is continuous on an interval a infinity. If f of x is continuous there, then we can talk of the integral from a to infinity of f of x dx. Then how do we evaluate this? Because we understand that we have infinity there, and infinity is not necessarily a number but just a symbol, and we cannot reach that. In other words, we cannot just substitute infinity after finding the indefinite integral in order to get the number or the definite integral. So what we do, we introduce the limit as b approach infinity, and then we change our limits from a to b f of x dx. So this will assist us to evaluate the integral from a to b. After that, we evaluate the limit. It's then that we will find the definite integral. Number two, you may find that f of x is continuous on the interval minus infinity to b, like this. And then what we do, the integral from minus infinity to b of f of x dx will be given by the limit when, say, a is approaching negative infinity. When a is approaching negative infinity, the integral from a to b of f of x dx. Again, we will evaluate the integral using a and b as limits. Afterwards, we evaluate our limit as a approach negative infinity. The third one is when f of x is continuous on the interval minus infinity to infinity, like this. And then in this case, the integral from minus infinity to infinity of f of x dx will be given by the integral from minus infinity, say, to a number c, f of x dx, then plus, then we start from c to infinity, f of x dx, where these two can be evaluated using the skills we used up here. So in this case, where c is any real number. So one other thing that is of importance is that if the limit is finite, in other words, when we evaluate this, we get a number which makes sense. We say that the improper integral converges, else we say it diverges. So if we don't get a finite number, then the integral will be divergent. Let us take some examples. Example, evaluate the integral from 1 to infinity 1 over x plus 2 the power of 3 over 2 dx. So as a solution, we observe that the integral from 1 to infinity of 1 over x plus 2 the power 3 over 2 dx is equal to the limit when b is approaching infinity of the integral now from 1 to b of 1 over x plus 2 the power 3 over 2 dx, like that. This is going to be equal to the limit when b is approaching infinity. Then we evaluate the limit here. You can see that if you differentiate this, you just get dx. So this is the square root, and then we to the power 3. So if we take it up, it's negative 3 over 2, and this is going to be equal to, okay, in other words, what I'm saying is this is the same thing as the integral from b of x plus 2 the power of minus 3 over 2 dx, like that, which is the same thing as the integral from 1 to b. If you let this to be your f of x, f prime of x will be 1. So we just add 1 there and we divide by what we get. So if you add 1 to 3 over 2, you get minus 1 over 2, and then you divide by minus 1 over 2. So we end up with minus 2 over the square root of x plus 2, like that. Sorry, we no longer need this, no longer need that. This, it's like this from 1 to b, which now can evaluate. It's going to be the limit when b is approaching infinity. We put b here, so we end up with minus 2 over the square root of b plus 2 minus, we put b here, it will be plus 2 over root of 3, like that. And then we are evaluating the limit when b is approaching infinity. So it will be the limit when b is approaching infinity of minus 2 over the square root of b minus 2 plus the limit as b is approaching infinity of 2 over the root of 3. Now for this one, you can observe, or you will recall, that for us to evaluate the limit, we do it like this. We divide throughout by the highest power of b in the denominator for the first one, which will give us 2 over square root of b divided by square root of 1 minus 2 over b. And this one is just 2 over root 3. So if that is the case, then we will observe that when we substitute infinity here, this will be 0, this will be 0, so it's 0 over the square root of 1, which is 0, and then plus that. So basically the answer here is simply 2 over root 3, which is the same thing as 2 root 3 over 3, like that. So let us take another example. Number 2, let us evaluate the integral from minus infinity to infinity of dx over 1 plus x squared. like that. So we understand that the integral from minus infinity to infinity of dx over 1 plus x squared, this will be equal to the integral from minus infinity to 0 of dx over 1 plus x squared plus the integral from 0 to infinity of dx over 1 plus x squared, like that, which is going to be the limit when, say, a is approaching minus infinity, the integral from a to 0 of dx over 1 plus x squared, like that, plus the limit when b now is approaching infinity, the integral from 0 to b of dx over 1 plus x squared, like that. This now is going to give us the limit. A is approaching minus infinity. What is the integral here? The integral is arctan of x from a to 0 plus the limit. B is approaching infinity, arctan of x from 0 to b, like that. So after getting that, we observe that this will give us the limit when a is approaching minus infinity of the arctan of 0 minus the arctan of a, first one, plus limit b is approaching infinity, arctan of b minus arctan of 0 for that matter. Then we understand that arctan of 0 is 0, arctan of negative infinity, it's minus pi over 2, plus arctan of infinity is pi over 2, minus arctan of 0 is 0. This will give us pi over 2 plus pi over 2, which is equal to pi. A wonderful answer, a nice answer to look at. A nice answer to look at. So finally, we may also discuss integrals of type 2. Type 2, where we have infinite discontinuities. Again, for this one, for more details, we encourage you to go to your notes and read page 66. They appear on page 66. In fact, mainly on page 67. Page 67 of your notes, then you'll find the different types and how they are dealt with. So because we just want to make this as brief as possible, we are going to look at an example and to illustrate how this works. Say for argument's sake, we take as an example, we want to evaluate the integral from 0 to 1 of the ln of x over square root of x dx, like that. Then we must make the following observation. We note that the integrand has an infinite discontinuity at x equal to 0. What are we saying? We are saying that at x equal to 0, if you put 0 here, the ln of 0 is not defined, and then ln of square root of 0, square root of 0 is 0. So you have some infinite, you have something which is not defined anyway. You have something which is not defined. Because it will be 0 here over, the ln of 0 over 0. It's not defined. So the function is discontinuous even at 0, because the 0 will be dividing by 0. Say if you have 1 there, then it's 0 over 0 again. We have a problem. So this kind of integrals are evaluated like this. We say the integral from 0 to 1 of the ln of x over square root of x dx. This is the same thing as the limit when, say, a is approaching 0 from the right. We approach 0 from the right. Then we talk of the integral from a to 1 of, let me write x to the power minus 1 over 2, the ln of x dx, like that. Now, to evaluate this kind of a limit, we may use what we call integration by parts. Let us say here, to integrate, say x minus 1 over 2, the ln of x dx, you let your u to be the ln of x, your dv to be x the power of 1 over negative 1 over 2 dx. Du will be equal to 1 over x. V, we integrate this, we add 1 there, it will be half x to the power 1 over 2 divided by half. So we end up with a 2, like that. So it is telling us that the integral of x minus 1 over 2 ln x dx is uv. Uv is 2 square root of x ln x minus the integral of v du. This is du. This is our v. So we have 2x to the power 1 over 2 divided by x dx, like that. This is 2, the square root, let me write square root like this, 1 over 2 ln x minus, then we are dividing here. When we divide, we get our 2, the integral of x, you subtract 1 from that, you get minus 1 over 2 dx, which will be 2x 1 over 2 there, the ln of x minus, then when we integrate, we're going to add 1. It will be a half divided by a half, and then it will be 4x the power 1 over 2, like that. So what we are saying is that from what we have done here, we are saying that this is the limit. A is approaching 0 from the right. Then the integral there is 2x the power 1 over 2 ln x minus 4x the power 1 over 2 from a to 1, like that. All right. So if we have done that, then it means this is the limit. A is approaching 0 from the right. Then when we substitute 1, this will be 0, and this will be a 4. So we'll have minus 4. And then we say minus. Then we substitute a here, which will be 2a square root ln of a minus, which will be plus 4a 1 over 2, like that. Right? And then now we evaluate the limit. We can see that the limit of minus 4 as a approaches 0 and the limit of 4a square root when a is approaching 0 both are easy to get. What the problem is with the middle part here. Problem is with the middle part. So what do? We are interested now in this limit. And then note that the limit, say 8 the power 1 over 2 ln of a as a approaches 0 from the right, it's equal to the limit when a is approaching 0 from the right of the ln of a over a the power minus 1 over 2, like that, which now helps us to talk about L'Hopital's rule. So if we apply L'Hopital's rule, we will differentiate the top, which will give us the limit. A is approaching 0 from the right, which will be 1 over a. Differentiate the bottom. When we differentiate, we subtract. So subtract 1, you get 8 the minus 3 over 2 times 3 over 2, like this. All right. This is equal to the limit when a is approaching 0 from the right. Then take this up, everything up. You will get minus 2 over 3. This is 8 to the minus 1. This one is coming, maybe I should write 8 to the minus 1 times 8 to the power of 3 over 2, like that. If we do that properly, we will see that this is the limit. A is approaching 0 from the right. A is approaching 0 from the right. And if a is approaching 0 from the right, then when we simplify this, we get minus 2 over 3, a 1 over 2, like that. Then when we evaluate the limit as a is approaching 0, the whole thing becomes a 0. So if the whole thing becomes a 0, when we come back here with a 2, it means what we are saying is that this limit will give us a 0. This will be a 0. This is also a 0. This is just a minus 4. Hence, what we are talking about, is that the integral from 0 to 1 of the ln of x over square root of x dx is equal to minus 4. Then you can look at the other ones. They are done this way. You just check where the discontinuity is, and then you replace that number by a or b and evaluate as an improper integral.